Hello, I'm Danni Sherwood. I'm an arachnologist. I study spiders, scorpions and their kin all around the world and in museums around the world too. Today I'd like to tell you a little bit about the research that I'm doing here at the Manchester Museum. So I'm a visiting researcher. I come here every year to study the collections, including the John and Frances Murphy collection of spiders, which is one of the best collections of spiders in any of the European museums. I study spiders from all around the world to figure out which species occur where and to name the undescribed diversity within spiders. I also work on a variety of other projects such as conservation and ecology projects. So today I'd like to show you a few of the specimens in the collections and talk a little bit more about the work that I've been doing here. So in this small jar that I have here, we have a tarantula. Tarantulas are probably the most famous of all spiders because they are amongst the largest spiders in the world. There is one spider that has a larger leg span than tarantulas, a very thin-legged huntsman spider, but in terms of body weight and bulk, nothing beats tarantulas. But as you can see, some tarantulas are actually very small. This is a fully grown tarantula from the Caribbean, and it's actually relatively small compared to some of these ones and some of the much larger ones that we have here in the collections. So that's a female, but what I'd really like to show you in a second here is the male. Males of tarantulas are sexually dimorphic. So what that means is the males, once they mature into adults, look very visually different to the females. And in many tarantulas, they have a special apparatus called a tibial apophysis, which is a hook on the front legs, which they use to put into the female's fangs to say, please don't eat me, when they're mating. So here's a male tarantula, and I'm just going to hold up to the side so you can see the hooks on his leg there. So you can see this hook just where my fingertip is. That is the hook he's using to say, please don't eat me, when he's mating. Male tarantulas also have boxing glove-like palps. These palps are where the genitalia are, which they use for mating. The shape of the genitalia is very important, and it's one of the ways that we tell different species of spider apart from each other. So I'm going to show you a few examples of photographs that we do. So for instance, in addition to doing the genitalia of the spider, we also take just general photographs of the spider. So here you can see a spider that was found in plant pots in a garden centre. It's not indigenous to Britain. It's actually an invasive specimen, but it's been intercepted, and we can now formally report this as a species that was found in plants in the UK. And this particular spider is a ground spider. It belongs to the family Nephosidae, and this is from New Britain. So this is actually from a fairly remote island. This could be something that's completely new. That's what I'm doing, is the investigation of the genitalia to try and ascertain whether this is a known species from Southeast Asia, or whether this could actually be a species that's new to science. If it's new to science, Diana and I will publish a scientific paper giving it an official scientific name. This is the palp of a wolf spider. Wolf spiders are called wolf spiders because they run and hunt down their prey, and they're often found in large groups, so people used to think that they hunted them together. So these are the special structures of the male. So as I was talking about in the tarantulas, they have a much more simple genitalia, whereas what we call our aranomorphae, our true spiders, which is the vast majority of the more recently evolved spiders, they actually are much more complicated. So they have structures like this. So in this male wolf spider palp, we have an embolus, we have a median apophysis, we have a tegulum, we have various membranes and different structures here, and the shape and the position of all of these different structures is used to tell the species apart. And this is much the same regardless of the family. Here's another very nice spider. This spider is called Hibana tenuis. It belongs to a family called Aniphaiinidae. You can see the genitalia is very different. It has a large structure that sticks out of the tibia. We call this a retrolateral tibial apophysis. And we have various structures here. Here's the embolus again. The embolus is what's used to insert and inseminate the female. And then various other structures like the median apophysis are here again. You can also see the sperm duct slithering down here like a snake or a river here. So really integral to the work here at the museum is this great microscope system, which the Manchester Museum Entomology Department has. This is a state-of-the-art Olympus system with a DP63 camera. This can take photographs of things that are less than 1 millimetre long and make them look like they're 1 foot long. So it's an amazing system, particularly for visiting researchers like me to study the collections. This is a really essential piece of equipment, and it's actually going to enable me, even just from this single visit, to produce probably 10 scientific papers. So far, I've already published around 15 papers on the Manchester collections over the years in my collaborations with Dimitri and Diana, and I'm looking forward to very many more papers in the future in this and future visits. In addition to the scientific collections, we also have display specimens such as these anatomically prepared tarantulas. in association with another researcher here at the Manchester Museum, Dmitry Loganov, who's now an honorary associate and former curator. We did a catalogue a few years ago of the tarantulas, and this also included the anatomical specimens, which we use a lot in teaching during the history of the university. Other great teaching specimens that we have here, prepared by previous curators in the early 1900s, are some large Pandinops scorpions and a large Scolopendra centipede. Scolopendra centipedes are the largest in the world. The very largest species of all, Scolopendra gigantea, gets to a length of 12 inches and hunts bats in caves. So these are a variety of the much larger specimens we have, but we also have a lot of very small, tiny specimens, tens of thousands of small arachnid specimens, which are just as important as these specimens and often contain the undiscovered diversity that we're looking at. So it's been a great pleasure for me to be here again for yet another year, working with Diana and Dimitri, and I thank very much the Manchester Museum for the opportunity to talk about my work. Thank you.